Fine. So yesterday I think we looked at some more stream classes, IO stream classes. Okay, and let's continue. And let's first look at a hierarchy for all the 4 classes. Right? So that will give you an overview. Oops, sorry. Okay, so let's start with, let's say, the output stream class. Right. See, we are looking at those which are part of the java.io package. Okay, and there may be other subclasses which are outside of the package, and we are just considering the ones in the java.io package. So yeah, if I look at the output stream class, and one of the subclasses which we have seen, we have subclass called the file output stream. And we have seen another one which is the byte array output stream. Another one, a filter output stream. Okay. Another subclass was the piped output stream. Okay, filter output stream again has subclasses. I think these are the ones we have seen already, right? Filter output stream again has a few more subclasses. One of the subclasses is the buffered output stream. Another is the print stream. And we understand that system.out, which we have been using, is actually object of the print stream class. Out, static variable in the system class, is object of this type, print stream. We have another class here called the data output stream. And the data output stream would extend from filter output stream. It's a second level stream, but it is implementing the interface called data output. Okay, so that's what is implemented by data output stream. We have seen what are the methods in the data output interface, right? Okay, handling all primitive types, handling strings. Okay, fine. What we also have is a sub interface to the data output interface called the object output. So we have this interface called object output, which would extend from the data output. It's an interface, and so 2 interfaces here, one data output and object output extends from data output. It adds only one method. Okay, there's only one additional method for object output. We have all kinds of write methods here, right? Writing for all primitive types. The additional method here is only one, okay, which is the method returns void. I'll put it somewhere below. Okay, so one of the method which is here, okay, is a method with the return type void. Name of the method is write object, and the parameter is object, any object. That's a method for object output interface. Fine. It has all the methods which we found in data output. Fine. It extends from data output but adds one more method called write object. Fine. Where any object may be written. And we have a class here. Fine. There is a class here called the object output stream. Which would implement this interface, but this class extends from the output stream directly. It's a direct subclass of the output stream. It's not a filter output stream or a subclass of the data output stream, something like that. Okay, it's a subclass of the output stream. Okay, so this would have all those methods which you have found in the data output stream. Data output stream methods are methods of output stream. Anyway, they are also found in the data output interface. So methods of data output. Those are the methods of data output stream. Object output stream has additional methods for write object. Fine, that's an additional method. Okay, so object output stream, yes, it has that method. Okay, I think what we haven't yet seen are these three things, right? Object output stream, the buffered output stream, and the print stream. Okay, so one is a buffered stream which will be for all four types. Okay. Object output stream, or even the object output, the data output interfaces, they are related to binary data. And so you won't find them in the character streams. And you don't have like anything like a data writer or data reader or object writer, object reader. Right? Okay. But yes, we have the buffered output stream. Similarly, there's a buffered input stream, buffered reader, and buffered writer. Okay. We have a print stream here, which is for output only. It's meant for output. And we have a print writer. We have also got a print writer. Recollect, writer implements appendable. Writer implements appendable, and same thing about print stream. So print stream is also implementing that interface called appendable. See, understand one thing. Version 1.0 did not have a writer.
So
print stream. It implements the appendable interface. Fine. It's a filter output stream but implements a appendable interface. Fine. print stream, and there is a corresponding print writer also, right? Print writer was introduced in 1.1. Okay. And print writer as a subclass of the writer. But one thing, method wise, yes, print stream inherits from filter output stream. So those write methods, those basic write methods are according to the output stream. But all other additional methods, any other additional method is exactly same as whatever methods you will also find in the print writer. So print stream and print writer are equivalent method wise. Method wise both are same. Whatever method you will find in print stream, same method you should be finding in print writer, and vice versa. Okay. 1.0 did not have a writer, but it was still handling text. What was print stream? What's the method we use from print stream? We have used, so far we have been using some methods on print stream for our output. We used it on system.out, print ln, printf. Okay, what do all these methods do? Whatever the input type may be, it has to always output a text. It converts to a string and outputs. Fine. Say in print ln, you might give any kind of data type. Whatever type you give will be converted to a string, and then that is what is going to be the output. Okay, so handling text was always there right from the beginning, 1.0, and this was handling text. But when they created a separate thing in 1.1, and because earlier there was no separation or separate kind of a streams which handle text, so they actually wanted to shift everyone to stop using print stream and start using the print writer. But anyway, something which has been introduced that can't be removed, and the very basic thing was system.out is a print stream, and system.out has been a print stream, and that can't be changed. Fine. Backward compatibility if you want to keep, when it couldn't be changed. So anyway, so they have maintained that this should remain equivalent of the print writer. So both are same. Okay. Actually they made a statement when they had come with the writers that let system.out and system.err be the only print streams that you use. You should be using print writers. Okay, fine. But that is what you may not find all the time, and you might find people creating print streams also. So anyway, they are both equivalent. And from methods point of view, understand print stream. Additional methods we know. Fine. We may have a look at the constructors for print stream, and almost similar constructors should be there for print writer. Print writer would have a few additional constructors. Okay, we have a buffered output stream, and then one of the things which we have to look at is the object output stream. We will be actually using this for our exercises. Okay, so this is the hierarchy for output stream. Okay, fine. Let's look at the hierarchy for input stream. Would be almost on similar lines. Yeah. Fine, we have the class called input stream. and subclasses. Yeah, similar to what we found for output stream, almost similar tree. Okay, so we have a class called file output stream, sorry, file input stream now. And there's a file input stream. There's a byte array input stream. There is this filter input stream. We have the piped input stream. There is also another one here called sequence input stream. Okay, that's also subclassing from here. Yeah. And under the filter input stream, yeah, one would be the buffered input stream. All buffered streams almost similar. We'll see what they are for. Okay, so there's a buffered input stream. There's a no, we don't have something like a print input stream or anything, but we have something called a pushback input stream. There's a pushback input stream as a subclass of the filter input stream. You have a data input stream, and there's a data input stream which extends from filter input stream but implements a data input interface. And we have a sub interface of this called the object input. Okay, which would extend from, so an interface called object input extends the data input interface, and a class called object input stream. This would implement the object input interface, and it extends from and this should extend from the input stream directly. Okay, additional method for object input interface. Data input methods we had seen, right, yesterday? Methods of data input. We had done, no? Huh. So the additional method in object input is read object. Return type? object. Fine. Method name is read object, no parameters.
So डेटा ऑब्जेक्ट आउटपुट में ऐसा नहीं होना चाहिए कि प्रिंट करे और ऑब्जेक्ट.
It's not about output, is not about printing. Fine. When I am saying write, I am sending it somewhere. It's not coming on the screen or something. It can go into a file. Okay. So yes, I want to store a int value. I have a write int method. I want to store a object. I want to store an object into a file, and I have a write object method.
So is the input menu
Writing, right? Storing it somewhere. Fetching it. What is read basically doing? What was stored earlier, it's giving you a copy of that. It's only giving you a copy of what was stored earlier. So what is read object doing? So it's creating a new object. Fine. Read object is creating a new object, right, which has the same state as the object which was written. You have to use read object only after someone has written an object. If someone has written an object, maybe the object's bytes have been stored in a file, so those bytes are used for recreating the object. And when you recreate the object, maybe you have the object of account which was stored. Okay, just take as an example that if I had stored the object of account using a write object method, and when I say read object, okay, it would create an object of, it should have been current account or savings account. So let's say current account. So what I read object, it should be creating object of current account. But understand one thing, when this object is created, the constructor of current account is not used. Normally, if an object is created, the constructor would be used. There are two cases when object is created and the constructor is not involved for that class whose object is being created. Yes, one case is this. What's the other one? Again, that won't always work. Okay, the same thing is true for here also. Read object. First thing is the write object may not work for all kinds of objects. Write object only works for which kind of objects? The objects which implement a interface called serializable. And we have the interface called serializable. So write object would work only for something which is serializable, and read object is recreating that object, but it is not using the constructor of that class whose object is being created. Okay, there's another case where a new object gets created without using the constructor. It's not with new. How do you create an object? One is with new. What is the other option?
Method.
Which method? No. If you are saying static method, it is again involving the constructor. From the static method, it would be calling a constructor.
Instance method.
Which one? No. Just like we have an interface serializable. See, it doesn't work for any object. Write object will not work for an object which is not implementing serializable. So same thing, that kind of a method, the method which is required there, okay, which is creating a new object, which is creating another object without using a constructor, needs to have some interface to be implemented. So there is another marker interface which we have come across earlier. I think we had done it for cuboid.
Readable.
We had done it for cuboid, which was using composition. Cuboid with composition, it implements some interface.
No.
The clone method. See, you call a constructor, that's one way. Fine. So constructor will be involved. But when you say clone, no, it's not involving the constructor. Fine. If someone was using a count variable and saying, okay, each time you call a constructor, I am counting it. Yeah. So I know how many objects are created. But no, that's not correct. Okay. Fine. When someone calls clone, it won't be correct for a class which implements clonable. When someone calls clone, the constructor is not used. Fine. When someone calls read object, the constructor is not used. The object gets created of a class whose constructor is not used. Okay. Fine. So two such instances, right, where constructor is not used but the object is created for a class. Fine. One was clone, other is read object, and both are creating a copy. Read object, just like the clone, na? What is clone doing? Creating a copy. Fine. Of an object which is still there, right? But this is creating a copy of an object which may or may not be there, which was existing. I know that it was existing sometime. Fine. Okay, fine. We'll be talking about the object streams, but maybe buffered streams we may have a look at first. Okay, there's the additional thing we have to look at. One is the sequence input stream. There's a pushback input stream. Okay, fine. These two plus this. Okay, buffered will be also seen, right? So we'll have a look at those things. Fine. Now coming to the writer class. Fine. I think won't be convenient to write it this way, because so let it put it in a vertical fashion, right? The classes. Okay, I am not showing it in a tree structure like that. Okay, because it won't come in the screen. So fine, let me start here. Let me see if we can write it the other way around. So we have this class called the writer class. Okay. The direct subclass is from here. Okay. Writer would have a we have what? Yes, the first thing we had seen was output stream writer. Another one. Okay, sorry, before going to the other one, let's finish with the subclass of the output stream writer. Yeah, subclass of the output stream writer, we have the class called which one? File writer. Fine, that's a subclass of output stream writer. Okay. Fine, writer class, other subclass, char array writer. Yeah. What else? we had seen yesterday. Piped writer. We even have the filter writer, or okay, we even have buffered writer is also here only, it's not under the filter. Fine, see the hierarchy wise slight difference. Fine, buffered output stream and buffered input stream are under the filter stream. Fine, here we do have a filter, so yes, we have a filter. We have a filter writer, that's okay. Okay, nothing ready made under the filter writer. Arrow should be this way. Okay, anyway, pointing upwards. Fine, we have even the, so we got a buffered, we even have a print writer. Again a direct subclass of writer. Okay. Piped writer is done with the, yeah. Any other kind of output stream was there? We had buffered. See, similar to what was there in for output streams. I think we had file output stream, we had a byte array, we had a piped output stream, filter output stream, buffered output stream, print stream was there, right? Yeah. We don't have anything for the data or the object things, okay? Yeah, so that should be it. Oh, there's also another one called the string writer. Yeah. String writer. Okay, so very flat. If I had done it that way, it would be like on both sides. So if you put writer at the center, oh, there will be all of these and all of this. So direct subclasses of writer are more. Fine. There is only one level otherwise, going to a second level, and nothing under the filter writer. Understand, filter input stream, filter output stream, they were in 1.0. Filter reader, filter writer came in 1.1, and that time they realized it should be abstract because it is designed for inheritance. It is designed to have subclasses which add functionality. Fine, the filter on its own is not doing anything. Okay. And let's look at the readers then. Reader, I'll again switch back to that old format. Difficult to accommodate everything. not difficult to accommodate all the things. Anyway, reader, the direct subclass, the first one which we had seen was input stream reader. Okay, let me first create those which have got further subclass. So input stream reader we understand has a subclass called file reader. We have the buffered reader. And it has a subclass called line number reader. So buffered reader has a further subclass in this case called the line number reader. Where do I put the? We have seen the other class called, I'll put it here, char array reader. As a subclass of reader, char array reader, and that's a subclass of reader. We have a piped reader, as a direct subclass of the reader. The other one is a filter reader. Filter reader has a subclass called pushback reader. Fine. So let's begin with these buffered streams first. Fine. The buffered input stream, buffered output stream, buffered reader, and buffered writer. That's common across all four. Fine. So we have the buffered streams. Constructors are similar for all four. Okay. So if I say buffered xxx, when xxx is one of those four, what does it take as parameter? That xxx, whatever it is. Fine, that stream input or output stream. Okay, let me just put some variable s for the stream. Input stream, output stream, reader or writer, whatever it may be, and a second parameter which is an int value for buffer size. Right? Or you may not specify the buffer size, in which case there is some default value for the buffer size. Okay. So the idea of a buffered stream is to add buffering. See how buffering helps. Okay, how buffering helps. So here, let's say for input side or even for output side we can check. So here is object of, let's say, a buffered output stream. Fine. When I create a buffered output stream, it would also allocate a buffer. The size of the buffer is what you can decide. Fine. And you can decide what should be the size of the buffer. Okay. When you write your data, any amount of data, it will first go into the buffer. It just keeps on writing it and putting it into the buffer, and when the buffer is full, okay, at that time this output stream, whatever the destination it may have, fine, that data will go in a full chunk of the buffer size. Fine. It may not be efficient to write 1 byte to a file each time. Fine. We should have a block of maybe 1K or 4K or whatever some size may be there, which is more efficient. That okay, if we write in that chunk size, that's an efficient way of writing to a file. Okay. Fine. So things can remain in a buffer. So you decide the buffer size. Fine. This is for writing side. Same way for reading, right? You don't want to be reading 1 byte each time. Fine. For each byte you go back to the file and then read from there. So first time you read, the first byte you try to read, it won't read 1 byte from the source. From the source it will fetch the full buffer size. Keep it in the buffer. Your subsequent reads fetch it from the buffer. When the buffer is empty and you still try to read next time, okay, fetch again that same chunk size. So you have a particular chunk size which is efficient for read or the write operation for that particular type of input or output stream, or reader or writer. Okay, so you decide what that value of buffer size should be. Right? So method wise, these buffered streams are not adding new functionality except for in the case of buffered reader. Okay. Fine. For buffered reader, yes, we have methods being added. Otherwise, what is buffered input stream? Same as methods available on input stream or the filter input stream. It's a filter input stream also doesn't add a method, right? Same way, buffered output stream, or whatever are the methods of output stream. Buffered writer, whatever are the methods of writer. Okay, but for buffered reader, so let's take the special case of a buffered reader, only one additional method. Okay, so we have the buffered reader. Constructor is same. I'm not repeating the constructor. We have always two constructors for any buffered stream. Okay, the additional method for buffered reader returns a string. Name of the method is read line. Okay, read up to the next end of line, fine, and create a string. So there's a read line method, and which is additional in the buffered reader. And you look at the hierarchy. Okay, buffered reader has a subclass called line number reader. Fine. Buffered reader has the subclass called the line number reader, and line number reader has two additional methods. The constructors for line number reader, oh, you can give a reader and the buffer size. It's a subclass of the buffered reader. So constructor wise similar to the buffered reader, line number reader. Okay, so if it's a line number reader, okay, fine, it would inherit the read line method. But what is additionally being done is it is providing two additional methods. Fine. there's a method to return int. The method name is get line number, and the other method whose return type is void, method name is set line number. Parameter is a int for the new value of line number. Okay. See, if I look at an object of a line number reader, fine, what is additionally there is internally it has one more instance variable. You can think it has a private variable for maintaining the number of lines it has read so far. Fine, some kind of a counter is managed. Fine, as you read, fine, as you read from a line number reader, if there is a new line which goes through, right, it has read some new line, it has come across a new line, whatever the counter may be, the value in the counter may be, it will just increment by 1. So that is like keeping track of how many lines I have read so far, and get line number is giving you the value in that counter, and it's giving you the value from the counter. And what is set line number going to do? न्यू लाइन रीड कर रहे हैं ना इसमें से. सी देयर माइट बी अ फाइल और एनीथिंग फ्रॉम वेयर, सो एज यू रीड, ओके न्यू लाइन गया, ओके एक इंक्रीमेंट कर दो.
लेकिन फाइल में तो सर इसका स्लैश से हम लगाते नहीं हैं.
हाँ,
अगर हम कोई फाइल में टाइप की उस फाइल को रीड करना चाहें तो उसमें स्लैश एन तो यूज होता नहीं.
हाँ, व्हाट इज स्लैश एन?
न्यू लाइन के लिए
escape.
हाँ, it is a escape character. It's not slash n basically. Slash n are two characters as if you look at it. No, it's not that. We have a backslash n to indicate a new line character. Fine. So buffered streams. Fine. Okay. Next thing, if you go back to the hierarchy in the input stream, in the input stream, yeah, we would come across something called a sequence input stream. And what is a sequence input stream? Let's see that. A sequence input stream, it has two constructors. One of the constructors says you can create a sequence input stream by using two input streams. So input stream 1 and another input stream called input stream 2. So you can create an input stream by using two input streams. A sequence input stream is created by using a combination of two streams, or we have another way, just like we have seen iterator, iterator. Fine, we have that interface called iterator for iterating over multiple elements of a particular type. Fine, you get next. Okay, now this collection framework was introduced in Java 1.2. Prior to that also we had similar kind of a interface which was known as enumeration. It was known as enumeration. Okay, enumeration has method like next element, okay, and has more elements. Instead of method like next and has next, we had method called has more elements, and next element, exactly similar to next and has next method. Okay, but the idea here is that yes, the sequence input stream could also be created by specifying an enumeration of input stream. This is nothing but input streams in a sequence, basically multiple input streams in a sequence. Enumeration, it's, you can think of enumeration as something like an iterator. Fine, so you are giving multiple input stream. First constructor says, okay, you give two input stream to create a sequence input stream, or another one says, okay, you got multiple input streams which are available from a enumeration. Right? If you want to create enumeration, look in the collections class. You will have static method where from a iterator or from a list you can create an enumeration. All such things are available. Fine? You will have methods which can create enumeration for you. And so in case you want to, you have got multiple input stream. But what's the idea for sequence input stream? So let's consider the first example itself, the first constructor. So if I want to create a sequence input stream, I would have specified two input streams to it, right? So there are two input streams which I have given for creating a sequence input stream. Now when I call the read method on a sequence input stream, it would start reading from the first one and give the data to me from the first one. I keep on reading, and if the first sequence input stream, first input stream here has reached end of file, fine, it would automatically switch to the second one and you get a continuous data. So it's like combining multiple streams to just create one stream out of it. Fine, you are putting input streams in a sequence and getting one stream from it. So combining multiple things, multiple sources, but going in a sequence one by one. Finish first one, second one, but one stream. So you have only one object from where you read and you get continuous flow. Okay, so combining multiple streams to create a sequence input stream. And so that was the sequence input stream. Okay, fine. Another one, we have pushback input stream and we have a pushback reader. There's a pushback input stream and a pushback reader. So let's look at those pushback things. What's a pushback? Fine. Either an input stream or a reader. There's nothing for output. This is meant for input. Yeah, input streams are meant for input, right? Normally, input and reader are there meant for input. Oh, but what is pushback? You got a pushback stream object. When you create the object of pushback xxx, let me put, but it would be either input stream or a reader. Okay, you need to specify xxx, it's a second level stream, and let's say input or a reader. I'll just say in, either input stream or a reader, and another parameter is in for pushback buffer size. Okay, yes, here also it uses a buffer. In pushback input stream, it has two things. There's a destination input stream. Okay, there's some destination input, some other source input stream from where the data will be fetched, and it has also got its buffer. Fine, which is a pushback buffer. It's not the buffer like the buffered streams. This is a pushback buffer. Okay, how the things work is like this. If you call a read method on a pushback stream, fine, trying to read from pushback stream, it will always first check if there is anything available in the pushback buffer. If there is anything available from the pushback buffer, okay, it gives you from there. If there is nothing in the pushback buffer, then it should go to the source input stream, that is whatever is your source, okay, and give the data directly here. No, whatever is in the source is not going in this buffer. This pushback buffer is not a buffer for the stream, and the pushback buffer is not the buffer for this stream, okay. It's fine. This buffer here would not act as a buffer for this stream. It's not for this. Okay. Okay. Then how does data come into a pushback buffer? Yeah, pushback. See, normally your direction is this, right? But a pushback is allowing you to have data pushed into a pushback buffer. You want to put something into a pushback buffer? No, you can do that. Fine. So the name of the method is, it's not called write. Oh, it would have been good, right, if we had a method called write. But yes, the same 3 overload which you see for a write method, that's a overload for the method called unread. We have this method called unread. So if I look at an input stream, we have the method return type is void, name of the method is unread, parameter int. For input stream it would be a byte, but for reader it would be a character, unread. So it's like push this byte or character into the pushback buffer. Okay, we have the unread method with a byte array or the char array in case of reader, byte array in case of input stream. Okay. And so that's your buffer basically, some array, this is your array. Or the other third one, what's the third overload for write? It's just the write method. You can see this is just like the write method.
Starting and length.
Fine. Offset and length. Yeah. Integer for the offset and another integer for the length. So these 3 additional methods are there. Fine. The method name is unread. Fine. So fine, that can give you an idea of some scenario where it might be used and where this can be useful. Okay, let's say we are processing a file. Fine. We have some text file which is being processed. In this text file, it may be a CSV data, right? CSV format. And maybe there is one of these fields. So this is made up of various records here. Okay. One of the fields in the record, okay, one of the fields here is saying what is the type of record, okay, type, and the file is ordered on that record type. Fine, the file is ordered on a record type, and I have to process first type of record, have some kind of summarization and all such things to be printed, and then start proceeding with the second type of record. I don't know how many records of the first type are there, and there might be multiple types like this. Okay, so what do I do? Read a line, process, read line, process, read line, process. Oh, when I read a line, I'll have to do a check on the type. Right? If the type has changed, then print a summary. Fine, print the summary and then go back to that routine which starts by read a line and process, read a line and process. See, I have written a routine which can do a read a line and process, read line, process, read line, process. Fine. And then once I find there's a change, I should print a summary and go back to that routine which says, okay, read the next line. Now if you are doing it that way, fine. For the second type, first type is fine, but for the second type of record, the first line is most likely to be missed out. Because how did you realize that a type of record has started? By reading the first record of the second type. You have already read from the stream the first record for the second type. See, there are 10 records of type 1. You actually don't know the count, right? So you have read the 11th line, then only you realized, okay, that I should be printing a summary. And then you are trying to go back to the routine which says, okay, read the next line. And what do? Miss the 11th line which was already read? Very likely. So what you can do in such a scenario? Push it back. Whatever I had read, unread. But yes, you see the unread says you give the data. It's not necessary what you have read, it would unread that only. But I'm just giving a scenario where you would probably unread what you had read. And whatever you had read, okay, put that back and then do the summary part. And then next time when someone comes up, okay, you will be reading what you had pushed back. That's the first thing. And once this is over, next is going to the source. Yeah, so unread, that's a method in the pushback streams. Fine. Pushback, that's the idea. Okay, what else was there? Print streams. Line number हो गया ना? Pushback is done. I think most of the things in. Okay, reader, I think everything is done. Writer में string writer एक है. Right. There's a string writer. That's the one in the writer. In the input stream, we have seen the sequence input stream. Pushback is done. Buffered is done. Data is done. Yeah. So object stream remains, right? It's an object stream which remains. I think, yeah, that's it. Okay. Fine. And maybe the print stream and the print writer. Fine. Print stream, print writer, and the object stream. That's what is the next thing. Yeah. Fine. Okay, fine. Quickly I'll look at the which was one of those left out, and the string reader, right? There was one class called the string reader. Object will take tomorrow. Fine. It can't be done in less time. It needs good time. We have the string reader. Fine. What is a string reader? Okay. A string reader, when you create, okay, here one thing you should know here is, you should know about a class called string buffer also. String buffer. You know what is this class called string buffer?
question, sir. A string buffer.
What is a string buffer? There is a class called string buffer. We have string class which is immutable, and string buffer is mutable. Sequence of, it's again a char sequence of characters. But in this you have methods like append and such things. Fine, you can append, you can replace a character within the, so it's a mutable one. Okay, so string buffer is a mutable thing. Fine, and we have this class called string buffer. What a string reader does is, like you had the char array reader, so not char array reader, you sorry, we had the char array writer. String reader लिखा है मैंने, string writer होगा.
String writer is that.
Not string reader, it's a string writer. This should have been a. So this is a string writer we are looking at. Yeah. Okay, so we have the yeah. So the idea of a string writer is like this. When you want to create the string writer object, fine, if you look at a string writer object, it is in turn creating a string buffer object. It's also in turn creating a string buffer object. When you write anything, it goes into the string buffer. It keeps on appending in the string buffer. Fine, it's a writer. Fine, where as you write, the things go in a string buffer. So it has an internal string buffer, but this thing, the idea of the string buffer is, it's not really a private thing. You have a method in the string writer. First thing, the constructor says int initial size for the string buffer. So this is used for initializing the string buffer size. I'll just say size here. Okay, this is nothing but size for the string buffer. String buffer in which is not yet populated but has a capacity. Okay, initial capacity for the string buffer, and when you write anything to a string writer, it goes in a internal string buffer, and you have been provided with a method called get buffer to return an object of string buffer. Fine. We have a method called get buffer which returns that object of string buffer which was internally being used. Fine. So the idea here is you can populate things into a string buffer, and then that string buffer, whatever has been written, can be used directly by you. Fine. With char array writer, we were writing into some internal array which was being managed, and then we had the method called toChar get it in the form of an array. Here directly a string buffer object is made available. And something similar to a char array writer, but not about a array, it's about a string buffer object now. What is given to you from the string writer is an object of string buffer. Fine. Whatever data you have written, that's available from a string buffer, and then you can manipulate the string buffer. Okay. Fine. Otherwise, it's inheriting from the writer. Okay. Well, tomorrow I think we can look at the other things, which is the print stream, print writer, and mainly the object stream. That's what we want, fine. And we would also like to use the object stream tomorrow. Let's see, we should. And what about this Saturday, Sunday का है कुछ नहीं हो
मैं इस सैटरडे जाऊंगा,
अच्छा सैटरडे को ही निकल रहे हो या संडे जाओगे कैसे?
सैटरडे को जा रहा हूँ, एक दिन साइड होने पे लग जाता है, संडे मंडे से स्टार्ट हो रहा है।
ओके, और फिर कब आ रहे हो? सैटरडे, नेक्स्ट सैटरडे है, उसके बाद सैटरडे कैसा है तुम्हारा?
हाँ वो मैं
चलेगा,
आप कहो तो आने बता दिया।
है ना? तो आई थिंक सैटरडे संडे रखे क्योंकि वो थोड़ा नेटवर्किंग थ्रेडिंग इम्पोर्टेंट वाला है। तो एंड थ्रेड्स का एटलीस्ट यू नो फर्स्ट लेक्चर होना चाहिए बिकॉज यू विल हैव क्वेश्चंस, ठीक है, यू विल हैव लॉट ऑफ क्वेश्चंस देयर।
सर तो फिर ऐसा कर सकते हैं क्या, ऐसे ये सैटरडे संडे आएगा तो फिर बीच में नेक्स्ट सैटरडे संडे ही डायरेक्ट?
ठीक है, सैटरडे संडे रखें, कल है फाइन, एंड देन ग्रुप में बात करके सैटरडे संडे रखते हैं, लेकिन चलेगा?
मेरा तो चलेगा सर, मैं
मेरा शायद चल जाएगा।
हाँ, हम लोग कुछ ऐसा कर लेते हैं, नहीं तो संडे नेक्स्ट सैटरडे संडे जब मिलता है तो संडे थोड़ा अगर लंबा रखेंगे तो भी देख लेंगे ऐसा। है ना, ये वाला नहीं, इसके बाद वाला,
हाँ
ठीक है।
वो आगे से क्या बोलते हैं, सिस्टम आर्किटेक्चर पूरा फुल फॉर्म पता है, आगे से ऐसा कुछ था, कंप्यूटर ऑर्गेनाइजेशन में आता है ना सर, वो हार्डवेयर उसके ऊपर एक लेयर होता है और उसके